Good morning, everyone. How are you all? I hope that all of you are doing amazingly great. First of all, welcome to this section. In this section, we will study the composition of function. Please note all the speech and the diagrammatic representation. Okay? This is very helpful class for CBSE student and joint aspirant. So let's get started. In order to understand the composition of function, we have checked three sets inside of me, which are A, B, and C. If we check the function f, which is moving from A to B, and the another function g, which is moving B to C. If we can take a random element x, after applying the function s, it becomes fx. Okay, and after applying the function g, it becomes g of f of x. This is the final product. In short, the new function from A to C is denoted by g compose f and is defined by g compose f set of f of x, g of f of x for all x belongs to A. Let f maps A to B and g maps B to C be two function. Okay. Then the composition of f and g is denoted by g compose f and is defined as the function g compose f from A to C is given by g compose f is equal to g of f of x for all x belongs to A. Okay. Next, we will discuss about this with an example. Okay. There are two very important points to be remembered. First of all, g compose f exists if the range of the function f should be subset of the domain of the function g. Okay. Again, f compose g exists if the range of the function g should be the subset of the function domain of the function f. Okay. You remember must g compose for g compose f. Here f is operated first followed by the function g, and for f compose g is operated first followed by the function f. Next, we will discuss about this with an example. Okay. For example, let f and g be two real valued function. F maps R to R and g maps R to R be two function defined by f of x is equal to x plus 1 and g of x is equal to 3x. We have to find f of f compose g and g compose f. Okay. Now f compose g, it becomes g of f of x. In the place of f of x, we put x plus 1. Then we get g of x plus 1. Okay. Here we see that g of x is equal to 3x. So this is becomes to 3 of x plus 1, that is 3x plus 3. Okay. For f compose g, it becomes f of gx. In the place of gx is equal to 3, we put in the place of gx 3x. Okay. F of x is equal to x plus 1. So f of 3x becomes 3x plus 1. Okay. Here we see that f compose g and g compose f does not equal to. A question may come out our mind, f compose g and g compose f are equal or not. We clearly say that f compose g and g compose f are not equal in general. Okay. The composition of the function is not commuted. Okay. For example, let f maps R to R and g maps R to R be two functions such that f of x is equal to sin x and gx is equal to x square for all x belongs to R. We have to find f compose g and g compose f. For f compose g becomes f of gx. Okay. In the place of gx, we put x square. Then it becomes f of x square. Since f of x is equal to sin x, so this is becomes sin x square. Okay. Next, for g compose f, we have g of f of x. Okay. G of f of x. In the place of f of x, we put sin x here. Then it becomes g of sin x. Since gx is equal to x square, so it becomes sin square x. Since sin x square is does not equal to sin square x, so f compose g does not equal to g compose f. So the composition of function is not commuted. But the composition of function satisfies the associative law. Okay. Next, if f maps A to B and G maps B to C be both injective functions, then the composition of F and G compose F maps A to C is injective. Okay. But the converse of the theorem is not true. Here one point is be noted. If G compose F is injective, then F is injective while G need not be. Okay. Next, if F maps A to B and G maps B to C both surjective, then the composition of this function is surjective. But converse of the theorem is not true. If G compose F is surjective, then G is surjective while F need not be. Okay. If F and G be two functions and both bijective, then the composition of F and G compose F is biject. Okay. If F function is even and G function is even, then their composition G compose is even. If F is even and G is odd, then their composition G compose F is even. Next, F is odd and G is odd, then their composition G compose is what? Okay. That's all for today. We will meet again in next class. Thank you everyone.